Okay, everybody. Good morning to you guys. Let's see, who do we have at home? Good morning to Caesar. Good morning to Blanca. And good morning to Panawat. Good morning to you, everybody here on a nice rainy day, right? Glad for the rain? Maybe, maybe not. Well, yeah, I know. Tell me about it. That's how it always works. You just wash your car and it rains. Anyway, all right. So let's take a look here at what we have online. And we have this trig cheat sheet. Remember, there's these various formulas on this cheat sheet, and we want to know where they come from. So looks like today we have these things called double angle formulas, which are very useful, and half angle formulas as well, that sometimes we use as well too. So we're going to look at some of these double angle and half angle formulas today, ladies and gentlemen. And, if you really focus on that, here we go. Double angle formulas. And we got half angle formulas. So here we go, ladies and gentlemen. Let's hope we did not. Yeah. Oh, sorry about that. Let's go back here. So we're going to focus on where we get some of these formulas. We got to get the iPad in. All right, we do have the iPad. So, ladies and gentlemen, here we go. I'm going to look at our book, and we're going to go in the order, and we say, well, what does the book have first? Oh, the book has the... Where are you, book? Let's make that bigger. Double angle formulas here. So notice a few things first. I want to go back and remind people where this actually comes from, right? So if I said to you, we're going to try to find where sine double an angle comes from. And here we go. Go back here to recall the sum and difference formula, or the sum formula, right? Sine A plus B is going to be sine A cosine B plus cosine A sine B. So let me move this over. You guys can't see that. Plus cosine A sine B. All right, you guys okay with that one? Question, yeah. Oh, sorry. What happened here? Where are you? That's odd. Are we plugged in? So odd. How come you guys are stuck on that? I know what it is. You guys know what it is? I know what it is. We have to move you over. I apologize. There we go. Weird. Weird. Here we go. All right, so here's what we're going to do. What are we going to do with this? Sine double an angle. Remember this here. Here's that first angle. And then here's the what? Second angle. First angle plus what? Second angle. So we get sine x cosine x plus cosine x what? Sine x. Is that right? You guys see that there? And so finally, what does this do for you? We get what? 2, what's this? Sine x cosine x. So sine double x will give you what? 2 sine x cosine x. And this is something I want to remark personally, that you do see this and use this quite often in math and science courses. So you guys want to know that there. Okay. So here's here's a double angle. Yeah, you guys see what I'm saying? You see how this is twice an angle? That means double angle. So there you go. A double angle identity. Okay, so there's the first one, and let me see if I can find it here to demonstrate. Yeah. All right, so you guys say, okay, here it is. To the left, the first double angle identity. Okay. Oh, okay, that's where that comes from. Now, similarly, if you said cosine double an angle, that's going to be cosine x plus x. And you might say, well, what do we have there? We have what? Cosine A plus B. Remember this. Cosine of a sum. That's going to be cosine A cosine B minus sine A sine B. So you're going to get, what are you going to get here? You're going to get cosine x. What is this? Cosine x minus sine x sine x. And that's going to give you cosine squared x minus sine squared x. Okay, so this is where this came from. Okay, so these identities, we're going to use these, and we're going to use these in our future. And they fell out. They just didn't fall out of the sky. They came from this sum and difference formula, so you guys know. Okay, so let's go look at the next one. And you go, well, what's the next one? We got, if we kind of find that, where are we at? Oh, we got more. Let me just kind of hone in on this one here for you guys. You guys see that to the left? Just to kind of be complete. You got two additional other identities, right? So let's express this here. Where do these come from? What do you guys think? Right? I'm going to do this here. So here's my first one. Okay. See this one here? Right? Cosine squared. I can replace that with sine squared. Is that right? Okay, you guys see that here? And I guess I have to be consistent with the colors. But then you get 1 minus what? Sine squared minus what? Sine squared. What does that give you? 1 minus what? 2 sine squared. So at the end of the day here, you have what? Cosine 2x, 1 minus 2 sine squared x. And here's the second version of that, right? Here's the second version. Right? And then similarly, if you said, what if I replace 1 minus sine squared with 1 minus cosine squared? Okay? What you'd get for cosine 2 squared x, this will be cosine squared x minus 1 minus what? Cosine squared x. Which will give you cosine squared x minus 1 plus cosine squared x, which will end up giving you 2 cosine squared x minus 1. And there you go. So, ladies and gentlemen, if you said, where do these other versions come from? This is where they come from. Okay? And again, are these things going to be used in our future? Yes, they are. You know, so I hate to say this. Well, no, I don't really hate to say. I'm kind of proud to say that. You know, I kind of give you the things that I know that you'll need and use in your future for the most part. And so these are kind of what we know. We have these double angle identities here. Okay? So today we're going to focus on the double angle identities. And then remark to you guys, at least for now, yeah, just going to give you a remark for some of these here. How about that? Let's give you guys some information about some of these. Let me find it. Let's find your questions here. It's weird. Okay. So a very common exercise that you guys will see will be to determine essentially, I don't think we did double angle tangent. Let's do that one. Okay? Then we could do the following. Let's go back to the sheet. Let's go back. Remember, we have tangent double an angle is double tangent 1 minus over 1 minus tangent squared. Now you say, where does that come from? Go back to the sum here. For tangent of a sum. Okay, do you guys remember this tangent of a sum formula? So if they said, well, what's tangent double an angle? You're going to go through the same exercise. Okay? So what is x plus x? You say tangent x plus tangent x, everything over 1 minus tangent x, tangent x. So here's what you end up with. you end up with this. 2 tangent x over 1 minus what? 10 to the squared x. Okay, so here's what you're doing here again. Doing the same kind of thing. So now we could use this. You say, what do you mean we could use this? They're going to say to us the following here. They're going to say determine sine double an angle, cosine double an angle, tangent double an angle. Okay, that's going to be your exercise. And the first one we're going to have will be, I'm going to say tangent. They'll define tangent for you to be minus 4/3, and they'll say x, or the angle, is in quadrant 2. Okay, so here's just the very common approach. I don't know if you guys have ever seen some of this before, but they're just going to try to see if you can use these these formulas. Okay, you guys okay with that? You know, the question is, can you use all of these formulas? Tangent double angle, cosine double angle. Let's color it in blue so we know. And there it is. So, ladies and gentlemen, how are we going to find out? Remember, notice how you use all of these here, right? Sine, cosine, double angle, and tangent. Let me remark here. Here's the key, right? You need what? What do you guys really need? You need sine and you need cosine. Is that true? So I just want you guys to understand that when they give you these kind of questions, in order to use all of these double angle formulas, you need sine and cosine. Okay, just kind of an observation. Now, how do we do that? Let's take a look here. Right, what's the definition? Go back and deal with it this way. Here's all of our information, right? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So in quadrant 2, remember we say all students what? Take calculus. So this angle, they're telling me for x is positive. Sine's positive. Cosine's negative. Okay, you guys okay with that? Easy breezy? But if I said to you, how do we get one of them? Right? Let's recall. We're going to use this idea that the reference angle is a quadrant 1 angle, and it's positive, right? So it's 4/3. So you see that negative sign becomes positive now. Opposite over what? Adjacent. Is that true? So how do you guys think you get the hypotenuse? What do you guys think? Hypotenuse is what? Isn't that 4 squared plus 3 squared? Is that right? So when you get the hypotenuse for this reference angle, I think you're going to get what? 16 plus 9 will be what? Square root of 25, isn't that 5? So here, this value is what? 5. Okay, you guys okay with that? Now, really from here, in all honesty, remember this, the quadrant 1 angle, it's a reference angle. So now we can say what? Sine of the angle is what? It's positive because the angle is in quadrant 1. Is that true? So how do we get sine? Do you guys know? Go to your triangle. What does a triangle say? What's the definition of sine? Isn't that going to be what? Yeah, opposite over hypotenuse. In fact, I can tell you, I know what cosine is. It's going to be negative. Negative what? 3 over 5. Okay, because I can use the quadrant 1 reference information to deduce the what? Quadrant 2 angle information, because the angle is in quadrant what? 2. Okay, so they're telling us this thing. Angle's in quadrant 2. So, ladies and gentlemen, I have really what? All the information I need to use these identities. Easy breezy, lemon squeezy. You guys see what I'm saying? So you're actually using the reference angle information and deducing what this, what those values would be. So if I say, okay, what's sine double an angle? Wasn't that the first one we did? Right? Here's the first one. Sine is going to be what? 4/5. What's cosine? That's right. So notice 2 goes away, and you're going to get what? Negative what? Is that negative 12 over 5? Double check. Where's my coffee? I'm sorry. I made a mistake here. That's not what that is. Sorry. That's what? We can't cancel anything. That's negative what? Yeah, 24 over 25, ladies and gentlemen. So there you go. Sine double the angle. Okay? We're just going to use that double angle identity. Okay, so the key is going to get sine and cosine. And then you say, okay, what's cosine double an angle? Take your pick. You got how many options? Boy, let's use the first one. How's that one? Okay. Use the first one there. So it's cosine. It's at negative 3/5. And what was sine? Do you know what sine is? 4 over 5. So you get negative 3/5 squared minus 4/5 squared. Is that right? Nine over 25 minus what? 16 over 25. What does this equal? Negative what? Is that negative 7 over 25? Okay. So here's cosine what? Double an angle. Easy breezy, lemon squeezy. So what's tangent now going to be? right? You need to have tangent. So you say, what's tangent going to be? Tangent's what? Negative 4/3. Right? So we know they gave it to us. Then they tell us that from originally. Here's what they're saying. Tangent's negative 4/3. Right? So we're going to use that because that's how you get the double angle. Tangent's negative 4/3. So up here, you're going to put a what? Negative 4/3. Down here, it's a negative 4/3. So what are you going to have to do with this? You guys know what we just did? We're going to have to use some arithmetic on this. Okay, you guys okay with that? You're going to have to do some arithmetic with fractions. So double check, is my arithmetic okay so far? Right? And then notice what I'll do here. I'll take this 9 over 9, and what do you end up with here? Negative 8/3 over, what's 9 minus 16? Negative 17 over what? Over 9, is that right? 7, sorry. And then, what do we do? Complex fractions? Say negative 8/3 divided by negative 7/9. You get negative 8/3 times what? Negative 9/7. What's a negative times a negative? 8/3 times 9/7, and then cancel the 3. Finally, you get what? 24 over 7. So this is tangent what? Double an angle. Right? Tangent, double an angle. There you go. All right, you guys okay with that one? Easy breezy lemon squeezy. Okay, so let me go to another one, and let's go to try another one of these. Okay, so another example here. These are the kind of things that we care about. How about this? Secant is 2. X is in quadrant 4. Okay. Now, I'm going to go back and remind you guys here. Okay. If they tell you secant is what? Secant is 2. What does that mean about cosine? Cosine is 1/2. Is that true? And so, as you guys know, if you actually have 1 and they'll give you 1, what are you going to need now? You're going to need sine, and you're going to need what? Tangent, okay? Now, saying the angle is in quadrant 4, what does that mean if the angle is in quadrant 4? You guys know? All students what? All students take calculus. Quadrant 1, quadrant 2, 3, and what? 4. So your angle is in quadrant 1. Okay? Oh, quadrant 4. Sorry. So X is in quadrant 4. So, okay. So if we say that, what does that mean? That just means cosine's positive. Is that right? Okay, so they're just pretty much saying to us cosine's positive, but that kind of makes some sense. I'm looking at this here. Because if they gave a secant, we know what? Cosine's positive. Okay? So if cosine's positive, then sine is negative, right? And tangent is negative. Let me go back and put it down here. Sine's what? Easy breezy lemon squeezy? You guys see what I'm saying? You guys see the logic behind it? So they're going to give you one. And so you now say, what do I do? Here's what I'm going to say. Look at the quadrant 1 reference. Right? Remember this reference angle? Everything's positive there. So what you're saying is cosine's 1/2. Okay, so I'm going to do my reference in purple. What's the definition of cosine? Yeah, adjacent is what? 1, hypotenuse is 2. What's the opposite side? Square root of 3. Is that right? Okay, so how do we know this? If we know how we know this, maybe you could use Pythagorean theorem, but it should be recognizable because this is a special triangle. See what I'm saying? That's all. This happened to be recognizable. It's a special triangle. Otherwise, you would use Pythagorean theorem here to get this side. What do you guys think? Okay, you guys okay with that? So that means I'm going to give you guys all the details here. Sine of the reference angle is 1/2. And I think we need tangent. Tangent is the square root of 3. Is that right? All right, you guys okay with that one? Isn't tangent opposite over adjacent? So it's just square root of 3? Sine should be square root of 3 over 2. Yes. Okay, we got that. Now, this is only for quadrant what? 1. This is for our reference angle. That's why I put this thing. This is my reference angle, right? You guys okay with that? So if that's my reference angle, what does it mean about the real angle? Sine's negative, tangent's negative. Is that right? So here's what this means. In terms of the angle, sine will be what? Negative what? Square root of 3 over 2. Tangent of the angle will also be what? Negative square root of 3. And then what's cosine? 1/2. So sine of a double angle. Yes, here what we have here. What's sine going to be? You guys know sine? It's what? Negative square root of 3 over 2. Is that right? And then what's cosine? All right. What do you think this gives us? Negative square root of 3 over what? I think it's just 2. Double check. Okay, that's sine a double angle. Okay, you guys okay with that one? Cosine double angle. You guys have that one memorized? I think I do. Cosine squared minus sine squared. You know, you could use either though. I think for me, I like to use this first one. Okay, but you don't have to. All right, you guys okay with that one? So we'll say, okay, we'll use this one. But I need to know cosine, and cosine is going to be what? 1/2. All right. Then I need to know what sine is, right? So what's sine going to be? Negative square root of 3 over 2. One half squared minus what? Negative square root of 3 over 2 squared. Is that true? What does this give you? 1/4 minus what? 3/4. Is that right? Okay. And what's 1/4 minus 3/4? And what does that give you? Negative 1/2. There you go. So what's tangent double an angle? Let's use this formula, but we need to know what tangent is, right? You guys see what I'm saying? So where's tangent at? Isn't tangent negative square root of 3? Two minus square root of 3 over 1 minus square root of 3 squared. Double check. Are we okay with that? Minus 2 square root of 3 over 1 minus what? And what's 1 minus 3? Is that negative 2? So what does this give us? Square root of 3. Okay, you guys okay with that? Easy breezy lemon squeezy. All right, not too bad. Not too bad. Okay. I'm going to give you guys one here. Okay, let's give you guys one to do here. So have you guys try this on your own. Cosecant here is 4. And then they're going to say tangent is negative. All right, here we go. We'll give you guys some time. Try this one yourself. All right, let's try this out. Okay, you guys know how to start. How do you guys start this? Yeah, what are they really saying to us, right? We're going to use the what? Reciprocal identity for cosecant. What does that mean? Yeah, it means sine is 1/4, right? Okay, using that reciprocal identity. All right, and then now notice the difference here. What did they just say? They didn't, yeah, they said tangent's negative. Is that right? They didn't tell us what quadrant, did they? The angle is. So you might say, okay, I have sine. They didn't tell us the quadrant of our angle. But let's all remember the following. All students take what? Calculus. Is that right? So tangent's negative in what quadrants? So I want to make sure you guys understand 2 and 4, what's the deal? Tangent's negative. Is that right? But what do you know? So you have 2 options. I'm going to make the claim that the angle is in quadrant what? 2. How do I know that the angle is quadrant 2? Yes, because even though they said tangent's negative, they also told you that sine was what? Positive. And so in quadrant 4, this means tangent's negative and sine is negative. Okay? And that would be contradictory. They're telling us sine is positive. We can't have a contradiction. So as before, you say, what's the key? What do we need? We need cosine and we need what? Tangent, just like before. So they may, they didn't give you and tell you directly what angle that's in, but that's okay. We know there's 2 options. That information is going to be clear. Okay, you guys okay with that? That's how you go about this. So it has to be in that angle. Now, you say, well, sine is 1/4. Okay, so now what I'm going to do is what I've been doing here. Go to what? Your reference angle in purple, right? Now, what you know about that reference angle in purple here, there's the x, that's x with the bar, that's the reference angle. Sine is positive. In fact, all of them are positive in the reference angle. Okay? All right, you guys okay with me on that? You're going back to quadrant 1, that reference, because we need cosine and we need tangent. And we'll get cosine and tangent very easily that way. And you say, well, how does that work? Well, here's how it works. Here's going to be, what's the definition? Opposite over what? Hypotenuse. Okay, so we need the adjacent side. Is that right? Now, how do we get this adjacent side down here? Right, we need the side here. How do you think we get that? Do you guys know? Yeah, I think we have to say what? I'm going to call that question mark. Or you can call it AB, doesn't matter, right? Maybe you want to call it A. I have no idea. What we know is A squared plus 1 squared will give us what? 4 squared. A squared plus 1 is 16. A squared is 16 minus 1. Is that right? So A squared would be 15. What does that mean about A? Plus or minus square root of 15. You guys know that has to be positive. Okay, distance is positive. So I got this side, I guess the adjacent side to my reference angle here. Okay, now you say, well, why is that important? Because we're going to need cosine of the reference, which is the square root of 15 over 4, right, by definition. And we need tangent. What's tangent of the reference? It's 1 over 4. This is all quadrant 1. So what did I do? Well, tangent is square root of 15. Opposite. Oh, sorry. All right, let's do this here. This is going to be opposite over what? adjacent. And that'll be the square root of 15 over 15 when you rationalize. Okay, thank you guys. So this is how we get this quadrant 1. This is all quadrant 1. Now, what do we just say is going to happen here in quadrant 2? In quadrant 2, sine is what? Positive. Is that right? But that means cosine's negative, and it means tangent's negative in quadrant 2. Okay? You guys okay with that? So they're both negative. Okay. So what does that mean? That means cosine of the angle will be what? Negative square root of 15 over 4. And it means tangent of the angle is negative what? Square root of 15 over 15. Easy breezy lemon squeezy. Just using all students take calculus. And that's something, like I said, it's kind of an interesting thing that, people overlook it. And if you said to me, sometimes I'll just tell you, you really want to know the purpose of these exercises, really, in all honesty, is to learn all students take calculus. That's the real purpose. In my mind, and to learn like what a reciprocal identity is, and and you're really looking at, comes down to arithmetic too, but I don't think personally at this point, arithmetic's important, but it's assumed that people can do it, right? What's not assumed necessarily is people understand all students take calculus, even though we've worked on it. And it's going to lead us at the end of the chapter to a very important kind of exercise. And that's why we have to focus on all students take calculus, and what that really means. And that's really what this is, in all honesty, in my opinion. So you now get 2 times, what's sine? Do you guys know what sine is? Sine is what, 1/4, is that right? So you get sine, which is 1/4. And then what's cosine? It's negative what? 15 over 4. And so you get positive times a negative will give you a negative, right? So I'm just going to do it, multiply my fractions, double check. Isn't that going to be negative square root of 15 over 8, right? There you go. There it is. Okay, that's kind of, in my mind, what it really is about. And then learning how to really look at this, these formulas, Cosine, double angle, if I go back, here we go. Like I said, I use the first one. And also the secondary part is to learn these formulas. So that cosine squared, cosine double an angle is cosine squared minus sine squared, because they're used at the end of the chapter. So all of these things that we're doing are ironically designed to support what you learn at the end of the chapter. That's my opinion. And cosine, you say, what's cosine? Well, it's minus square root of 15 over 4. Is that right? And then sine, we know what's sine. 1/4. So what does this give you? 15 over 16 minus. And what does that give you? What's 14 over 16? 7 over 8. There you go. And that's what this is really about. There it is. 7/8. Tangent double an angle. You say, what's tangent double the angle? Oh, here we go. I'm going to erase this here. And we just have to plug in the tangent now. What's tangent? Is that negative square root of 15 over 15? Okay. So what do you guys think? What happens now here? This is negative what? 2 square root of 15 over 15 over 1 minus, what's this? 15? I'm going to do a 15 over 15 squared. I'm going to be clever here, right? You guys know what I'm saying? Why is that kind of good to do? I mean, if you know what that is, that's fine, right? Is it 1 minus, is that 15? Is that 15 over 15? Which is what? Minus 2 square root of 15 over 15. Everything over, isn't this 15 minus 1, which would be what? 14 over 15. You guys okay with that? What was that? Yeah. Well, here's what I'm going to do. You see this portion here? Here's where the question is. This is going to become what? Isn't that 15? 15 times 15. So that becomes my, you say, what is that? That's 1 over 15. That's over here. So 15 minus, that's 14 over 15. Okay, you guys okay with that one? Now, I'm going to say this. You guys realize something. What's going to cancel? 15. When you divide, right, you can get 2 square root of 15 over now 14, and then that'll be now a 7. So it's negative square root of 15 over what? 7. Okay. So, there is some arithmetic that's going to go on here. There you go. All right, you guys okay with that one? There it is. So we're going to kind of take a look here at the half angle portion, right? Half angle. Let's look at these formulas here. So you guys see this half angle formula, cosine squared is 1 on the upper right, these 3 formulas here. Okay, so you might say, where does that come from? Half angle. So I'm going to go back here. Okay. So look at these half angle formulas. Okay, so let me go back. So you have this relationship here. They say sine squared theta, and this is going to be an extremely important formula, is 1 minus cosine double theta. So I'm going to give you that first one, and I'm going to give you the second one here. Cosine squared theta is 1/2 1 plus cosine double theta. Okay? These are called half-angle formulas here. And I'm going to express to you where it comes from. But, I'm going to start here with these. Even though they're half-angle, you go, where's the half? Right? You go back over here. Even though they call them half-angle formulas, you got sine squared is 1 minus cosine 2 theta. Cosine squared is 1/2 1 plus cosine 2 theta. And to ask you guys, where do you guys think that these come from? Does anybody know? Right? If I go back over here, let's look at this. Go back to these here. If I can find it. Okay. You see these two formulas here? So I'm going to take this, I'm going to take both of them. And copy that. Show you guys where it comes from. So I'm going to move this here. I'm going to move this one down. So I'm going to start with this one here, okay? So we already have this formula. And easy breezy. Let's do what? See this? Let's just solve for sine squared. And I'm going to translate. Do you guys remember what does translate mean? If you move a term to the other side of the equal sign, right? All you got to do is what? You can move terms to the other side, but change the sign. The sign. It's really a shortcut for the addition method. So you might say, does that give me over here 2 sine squared x is 1 minus cosine double x? Is that true? Okay, you guys see what I'm saying? Now what am I going to do? Just divide both sides by 2. Okay? And you end up with sine squared being, I mean, you could write it this way too. Sometimes people see it as this. So I'm going to derive some of these formulas here for you. Okay? So now, we solve for sine squared. Is that right? So you say, oh, is that where that formula came from? But I just want you guys to know, why do they call it half angle? Okay? Because they say, I don't see any half angle anywhere. Do you guys see a half angle anywhere? I don't. Let me share with you guys why they call it half angle. If we let x be maybe theta over 2, okay? So you put this theta over 2, you end up with what? Sine squared theta over 2 is 1 minus cosine of what? Just theta over 2. Okay, you say why? Because what you put in here for x is theta over 2, and doesn't the 2 cancel? And by the way, isn't this now a half angle? Okay. So this is the half angle what? Version of that formula, just so you guys know. They just changed the variable. So this is why they call it half angle. Now, go back to the other one here, cosine. What do you want to solve for here? Solve for cosine squared. Translate. Or just move that term on the other side, and you get now what? 1 plus cosine double the angle 2 cosine squared. Divide now both sides by what? 2. You get cosine squared 1 plus cosine double the angle over what? Over 2. Okay. So this is another formula that we're going to use that's going to be extremely important for us. We just solved for cosine squared. Okay, this is a very interesting formula. I just want to express to you guys what's so nice about this formula. What do you guys notice here? Just to kind of express it to you now. You guys see this here? Pay attention to this detail. I'm going to put it in green. Here's a power 2, and then here there's a power 1. So this is known as a power reducing formula. Okay? It's power reducing. That's what this is known as. So you say, oh, is that why I care about this? Yes, same reason. I'm going to erase this. This is what again? I'll put it in green. I'll emphasize it in green. This version here is power what? Reducing. That's going to have some meaning for us tomorrow. You went from power 2 to a power what? 1. Okay, power reducing. This portion again, now here, you say, why do they call this stuff half angle? Well, I'll do it over here, right? In red, we're going to let x be theta over 2. So this now becomes a half angle. And then half of theta over 2 is just theta. So you say we get now cosine squared theta over 2 becomes 1 plus cosine of theta over 2. This is a what? Half angle formula. Theta over 2. So you got power reducing, you got half angle. Okay, you guys okay with that? Easy breezy, lemon squeezy? I'll give you the last one here. You go, oh, what about tangent squared theta? Well, this is sine squared what? Theta over what? Cosine squared theta. So you said, what was sine squared theta? Well, it's 1 minus cosine double theta over 2. And then it was cosine squared theta. We just seen this one right here. That's plus. So remember, sine squared theta is 1 minus cosine double theta over 2. 1 minus. Cosine is 1 plus. What do you do with the 2's? Cancel. What do you have left? Tangent squared theta is 1 minus cosine double theta over 1 plus cosine double theta. And I guess they have that one. Yeah, they have that one in your book here. And you can say, is that angle reducing? Yeah. You say, what about half angle? Well, this is now theta. Doesn't matter. I should have put x, but it doesn't matter. I'll be consistent. X, x, x. What do you let x be here? Let x be what? Theta over 2. Theta over 2. Theta over 2. Just like we did before. And I'll keep it in red, I guess, I think. That's now tangent squared theta over 2, going to be 1 minus cosine what? Theta over 1 plus cosine theta. Okay, so this is known as your half angle version. Okay, it's known as a half angle version. So if I look at this formula here, you know, it's kind of weird. If I look at this sheet upper right, notice you don't see any half angle, do you? In that summary, right? But I think you should. And I think your book, does your book do that? Sort of. It doesn't give you this exact version. We'll talk more about the version tomorrow, but they give you some other versions we can share with you about how that works. But it's where it comes from here. So anyway, let's go scroll out. And let's do this here. So this is all in 7.3. And I could just say, just for now, all you can kind of just do for now until we look at these other formulas is the following. You can kind of just do 1 through 8 all, you know. And we'll continue with these, you know, in our future. Yeah, 1 to 8 all. All right, where am I trying to get to? Right here. All right, we'll see you guys later. Stay dry. Hope you guys have a good day. Take care. We'll see you tomorrow morning.